Hi everyone, welcome to GemChem. Now today's topic of discussion is the historical background behind the coordination chemistry and Werner's theory. Now before starting, already 4 videos of coordination chemistry are uploaded in channel. You can watch it. I will give the link in the description box as well as the I button present above this video. And if you are new to GemChem, do not forget to subscribe the channel. So let us start. So what was the historical background behind the formation of coordination chemistry? The modern study of coordination chemistry began with 2 scientists, namely S.M. Jorgensen and another one was our famous Alfred Werner. So, although Werner's idea eventually established, this did not invalidate the Jorgensen's findings. Jorgensen created no new structural theory of his own, but he logically and consistently extended and modified Blomstrand's chain theory to interpret the complex compounds made by him. In 1893, Werner challenged this theory with a new theory based on the compounds synthesized by Jorgensen. Werner was the first inorganic chemist who was awarded Nobel Prize in 1913. So let us see the Werner's theory by seeing the different approaches. So what was the approach to Werner's theory? While Werner was working, before giving his postulate, he had the following information in his hand. These are the complexes which were present with different colors and they were named differently. On adding HNO3 to them, they saw that the release of 3 equivalent AgCl occurred from compound A, 2 equivalent from compound B, 1 equivalent from compound C and 1 equivalent from compound D. And this indicated that there were ionizable Cl- present in it. So, on these complexes only, Werner performed conductivity experiment with all these compounds and he found that these compounds behaved as 1:3 electrolyte in case of A, in case of B it behaved as 1:2 electrolyte, for C it behaved as 1:1 electrolyte and for D it behaved as 1:1 electrolyte. So from here he concluded that the compound A might have been this one. That is, it is having cobalt in within the coordination sphere, then 3 chlorine outside due to the presence of 3 ionizable Cl-. For B, there was 2 Cl- outside, so he wrote this as NH3 whole 5, 1 Cl inside and 2 Cl outside. C and D could have been concluded as CO NH3 whole 4 and Cl2 and Cl. So from this above experimental result, Werner proposed some postulates. So first he proposed that each of the metal ions in the complex exhibits 2 types of valency. One is primary valency, where it is indicating oxidation state of the metal, and another is secondary valency, where it is extending the coordination number of the whole coordination sphere. Secondly, he told that the primary valencies are satisfied only by anionic ligands that may or may not be present within the coordination sphere. Thirdly, he told that the secondary valencies are satisfied by both neutral as well as anionic ligands that are present within the coordination sphere. Fourthly, he told for a given coordination number, the geometry around metal ion is always fixed. We have already learnt about VBT. So, in case of VBT, the number of electrons guided the geometry. Similarly, in this case, the coordination number guides the geometry. And the last one is that the coordination number which we are considering exhibited by a particular metal ion is always fixed, but it may get different for different metal ions. So these were the postulates of Werner's theory. Hope this was helpful. This much for today. In the next video, we are going to deal with the most important topic, that is IUPAC nomenclature of the complexes. So, thank you for watching. Do not forget to like, share, subscribe and comment.